Hi everyone. Okay, so everyone, let's get started. So everyone, this will be the agenda for today's session. So basically in today's session, we will discuss why data science, what is data science, how a problem is solved in data science. We'll be talking about data science component and I'll be showing you one small set of code. Okay. So yeah, let's get started. But before we get started, I would like to set the expectation here very clear, and that is this session is just to give you the introduction on data science, or this is just to make you familiar with some commonly used terminology, or this is just to make you, aware about the role of a data scientist, or like what kind of work you will be doing once you enter into this domain. So in today's session, we will not be discussing any of the component in detail. Okay, this is just to give you the overview, or this is just to give you the complete picture about data science. Okay. So first of all, guys, if I talk about data sources, right, even you know that today we do have variety of data sources. So let's look at the data sources, right? So guys, first of all, data is coming from n number of sources these days, right? Data sources as in from where and all data is getting generated. So when we say that huge amount of data is getting generated today, so what is the first main factor? That's nothing but the evolution of technology, right? So you know, right? Like some time back, like 10 to 15 years back, we were using telephones. Now we are using mobile, right? Or we are using smart devices. So what is the change here? Not because we have started using smart devices, right? We are generating huge amount of data. What do we have here? Just like we were using desktops, now we do have cloud. Cloud means like we can store huge amount of data, we can upload and consume, right? And we are dealing with smart cars as well. Smart devices everywhere. What is the outcome or what is the result? Huge amount of data is getting generated. Next, we have IoT. IoT is nothing but Internet of Things, as in we will be connecting all the devices which we have in our houses to internets and will be consuming the data. It's like now sensors will be there in each and every device, and that device will continuously be generating the data. Right? Then what do we have? We do have social media platforms. Again, huge amount of data is coming from social media platforms as well. These are the stats for all the social media platforms for a minute. Per minute for YouTube, 300 hours of video is getting uploaded. So you can imagine the amount of the data which they will be storing at the end of the day. So yeah, and also you need to imagine the speed at which data is getting generated for them. So now for Twitter, these many tweets per minute, for Gmail, these many emails per minute, right? Social media and other factors, again, in each and every domain, right? Huge amount of data is getting generated. So we can talk about retail, banking and finance, media and entertainment, healthcare, education, government, transportation, insurance, right? So in each and every domain, we do have a huge amount of data. So now there's this use case, okay? So basically, Walmart, right? So a data scientist at Walmart, he founded a connection between Halloween and the sales of cookies. So basically here, it's like what data scientist did. Data scientist found a connection between Halloween and the sales of cookies, right? There is one more use case. Walmart, right? Again, they found sales of strawberry Pop Tarts increased by 7 times before a hurricane, right? Again, they've founded a connection. So we need to understand, like, on what basis they are saying that there is a connection between a strawberry Pop Tart and a hurricane, right? And also, what Walmart is doing, Walmart is leveraging social media data to find out the trending products so that they can be introduced to the Walmart stores across the world, right? Everyone is interested in increasing the sales, so they need to understand the customer behavior, they need to understand the consumer pattern, right? Accordingly, they will be manufacturing the products and accordingly they will be selling, right? And yeah, that's how they can increase the business, right? So now question is, what kind of a company needs data scientist? Every kind of company needs data scientist whenever it comes to making the prediction, okay, or whenever we say that we are interested in increasing the sales. So tell us what are the areas we can improve. And also, if let's say that, if I talk about supply chain, right? So there also we need to know, right, which area is having more demand, which area is having less demand, and accordingly we will be manufacturing the products, or we will be distributing the items. So all these things, right, they would be done by data scientist. Whenever we say that, okay, tell where we should be spending more, spending less, what is the pattern, how can we improve, all these things will be done by a data scientist. So you can take example of any company. Microsoft has data scientists, okay? Google, Facebook, everyone is having data scientists. Now let's understand what is data science actually, okay? So basically, guys, it's nothing but it's a data-driven science. Let's say that you are a data scientist. You are here. You will be given the data set and you will be given the requirement. I'm giving you the stats related to the sales of cookies, and I am giving you some data related to Halloween. Now you need to find the connection between them. That's your job. You need to find the relation of cookies with the Halloween. Okay? Or you need to find the relation between the strawberry tarts and the hurricane. Right? That's what your job is. So as in you will just be given the data. So now you need to know a method, or you need to know a process using which you will be finding the relation. So the formal definition of data science says that it's called data-driven science. It's an interdisciplinary field about scientific methods, processes, and systems to extract knowledge or insight from data in various forms. Now the data which will be given to you as a data scientist, it can be of any form. It can be structured data, it can be unstructured data, it can be semi-structured data. What you need to do on that data is you need to apply the scientific methods, processes, and systems to find the relation, or to understand what is happening or what this data is telling. Okay? A question that usually is asked to data scientists is, tell us something that we don't know, right? And how would you be doing that? So how would you be doing that? It's like you will be, you need to have, first of all, good domain knowledge. Then you need to know statistics, and then you will be implementing, or it's like you will be writing the programs to understand the relation. So as a data scientist, you need to have expertise on statistics, programming, and also you need to have domain knowledge as well. So yeah, these are the steps which we follow while solving any problem in data science. First of all, discovery and data preparation. This is very important. Okay. So you need to understand like what kind of data you have got. Okay. And you need to check like if the data is enough or not, right? You will be doing all these things. Then you'll be preparing a model. Okay. Then you will say that, okay, this is the algorithm which I should be applying. Then model will be built, then you'll put it to the prod, you will get the results, and you'll keep on working on that. Now let's discuss in detail one by one. Okay. First of all, discovery. So discovery, as in it involves acquiring data from all the identifier internal and external data sources, right? So basically now you will say that, okay, we know that, yeah, data is not enough and we need more data. In that case, what you'll be doing, you will be doing the integration with third parties and you'll get the data, or you'll say that, okay, we need this detail as well, right? And this data, right, it can come from web servers, social media data, census data set, or it can be any kind of data. First of all, collecting the enough amount of data. More the attributes, more data you need to have. Let's say that someone is giving you 10 attributes, right? So in order to find the relation between all those, you'll need less data. But someone is giving you 1,000 attributes, then you need, in order to conduct your research, you need more data. So now let's say that this is the medical history of a patient. Okay. This is the medical history of a patient and you have been given this data set. Okay. Where you say that, we do have number of times pregnant, glucose level, BP, okay, BMI, diabetes, pedigree, function, age, income. Now you know that income is irrelevant attribute in the prediction of diabetes. It has nothing to do, right? Now, when it comes to the data preparation, guys, this is where 70% of the work would be done. And what we do as a data scientist in data preparation, as in, we will be cleaning the data. Okay. So because you will be getting the raw data from the sources, right? So sometimes you'll get junk values, sometimes you'll get missing values, right? So what you'll have to do is you'll have to clean the data. And when it comes to cleaning on of the data, there are n number of things. Okay. So basically, if you look at this data, right, what we have is, so basically this data has lot of anomalies, right? As in, this is like for this value, right? But for this column, number of times pregnant, we see that all are numeric values, right? But here we see one, right? And for glucose, you see missing value. That's not correct, right? For a patient, how is it possible that no value of glucose is found? Now tell me, can BP be this much high? No, it cannot be, right? Again, BMI is null. And income, we don't need it, right? So what you'll have to do is, you will have to find out the ways using which you will be replacing this null value with some value. Now you cannot do your research, or you cannot start your research work until you have the value of the glucose, right? So now you will have to find out the ways using which you will be replacing the value, or you will be putting some value of glucose here. So there are different ways, as in some would take mean, right, of all the values, and then they will put it here. Someone would take median of all the values and they will put it here. Now, this is your job as a data scientist to check, like, if with mean you are getting the proper result, or if you are getting it with median. Okay, let's say now I'm saying that there are two ways, we can take the mean or we can take the median. Now let's say for age, right, age is missing. For this age column, I have a null value. So now let's say there is this newborn. That's why the age was null. If you take the mean, or if you take the median of all the values, and let's say that age comes out to be 40 for that newborn, do you think you will be doing the right kind of research or analysis? No, not at all. So this is what your role is as a data scientist. Formulas are there. Data science is all about applied engineering, or it's all about applied mathematics. Whatever we had studied in our mathematics or in our engineering, right, related to mathematics, this is the field where you will be applying all those things. We studied differentiation, integration, right? I don't think so we are using that while writing a program. But now when it comes to data science, you need to have good understanding of statistics. You will be, applying all the formulas, differentiation, integration, and all those things you'll be doing now. This is what, okay? Now there is one more thing. Let's say outlier, okay? The requirement is to find the average salary of all the developers in an organization. Now for calculating the average salary of all the employees, do you think you should be considering the salary of CEO as well? No, because in that case, right, your average will go quite high. So what is that? That's nothing but an outlier, right? So you'll be doing research where you'll say that, okay, this is something which we should not be considering. Then let's say that you do have some string values, okay, or it's like here you see numeric, right? One thing is machine understand everything in terms of 0 and 1. So you'll have to work on the ways using which you'll be converting all these values in form of 0 and 1. So now if I data preparation, right, you see we have filled the values. R is for the statistical analysis. As in, I'm talking about data preparation and data cleansing, right? So R has got inbuilt functions which you will just call and it will make your job easy. But it's not that without knowing the mathematical concepts, you can, excel as a data scientist. No, that will not work. Basic understanding of mathematics, or the mathematics which we studied in our engineering, right? That's very much needed. Our APIs in Python like Panda and NumPy, or in case of Spark, right, we do have again a machine learning library. So those are like function is already there. If you need it, you just call it. But now you need to know which function to call and why. That's important. So yeah, now this is about model planning. Okay, so what you will be doing basically now, you will be determining the methods and techniques to draw the relationship between variables. You have done the data preparation, and now you need to do the model planning. So what is this model planning? Basically, now you will say that, okay, now let's find out the relation. And this model planning is nothing but the implementation of machine learning algorithms. In this phase, you will be implementing machine learning algorithms. So when it comes to machine learning algorithms, again, you need to know what all algorithms we have, which algorithm to apply for finding the relationship. And what you do usually in data sciences, you implement couple of algorithms and you try to find out the best result. Okay, so it's like, let's say today you have implemented linear regression, so the relationship is not clear. Then you will implement linear regression or random forest or decision tree or things like that. Model planning. Okay, in model planning, it's like you can visualize the data. So now it says that okay, glucose, BP, BMI, this is the graph. It says that yeah, this is the relationship. Now, what you'll be doing, you'll be building the model. So for building the model, you can use our Python statistic. I told you, right, that the loan eligibility calculator, right? So basically, it is running as a web service, right? So yeah, what you'll be doing, you will be building a model, and then you will be deploying it to prod. Okay, so it's like now it's there. You have tested it properly. Whatever you have developed, right, that is something which you need to deploy, right? It's nothing but the model building. Then what you'll do, you'll put it to like you will do the analysis. Objective is to find out, right, if a person will have diabetes or not. So it's saying that, okay, if this is the value, this is the value, then negative, not positive, yes. Operationalize, you'll put it to prod, and then you'll be communicating the results, right? And after this, right, so let's say that your model is giving 80% accuracy, right? And nowadays, right, 80% accuracy is not enough, especially in terms of healthcare. Objective is to get more than 90%, right? I told you, like what you did, like this API or this function to call, and you have done everything, and now you are getting the accuracy as 80%, but that is saying that no, we are interested in getting the accuracy of saying that we are interested in getting the accuracy of 90%. So now you will say that okay, I have done the data cleansing, I have done the data preparation, that's fine. I had just called this algorithm, that is also fine. Now what else do I do? There you need to know how that algorithm is working internally. Okay, you need to know the detail, you need to get the detailed information, and you need to understand that this is how this algorithm is working internally, this is the mathematical formula which is working, and this is how we can optimize it. Okay, so yeah, this is the result. It says this is the diabetes positive set, this is the negative set, and now with this set we can know if a person will have diabetes or not. How to choose an algorithm in data science. So guys, when we were talking about what is the eligibility, eligibility, you should be good in mathematics and programming. That's the eligibility. And if you are not, if you are interested in putting up like 200% of your effort, you can always go with that. If you don't think that you do have expertise but you are really interested in learning, then yeah, you can go for this. The only thing is you would have to put so much of effort. So let's see, how do we choose an algorithm? Okay, so guys, now let's say that in model planning, right? So you need to apply the correct algorithm to find the relation, right? Your objective is to find out the relation. So here, what do you see? So basically, here, right? So if someone is saying, so basically in case of machine learning, we do have classification algorithm, anomaly detection, regression, clustering, and reinforcement. So now let's say that someone is saying that, tell me if this is A or B, then you need to go with the classification. And if someone is saying, is this weird, then anomaly detection, how much or how many, right? We talked about loan scenario, right? Where I said that, okay, if the calculator is saying that, yes, person should be given the loan, then you also need to find out like how much loan should be given, right? So that's where the regression algorithm would come into the picture. How is this organized? As in, now for your website, right, you are interested in creating the groups based on user preferences. So it's like you'll say that, okay, tell me, how do I organize this? How is this organized? And then what do you have is, you do have like, what should I do next? This is about reinforcement learning, this is about reinforcement learning, or this is about, neural networks or deep learning, autonomous cars and all. These all are examples of reinforcement learning. So now you need to understand these algorithms in detail, like how are they working. So now when we talk about the categories of algorithm, right, here what do we have is, we do have supervised learning, we do have reinforcement learning and unsupervised learning. So let's understand what is the supervised learning. Okay. Supervised learning as in, you have the historical data. Okay. Supervised learning as in, customer is giving you this data and customer is saying that last time when customer was having no car, no personal loan, own house, monthly income more than 50,000, person was capable of repaying the loan. Person repaid the loan, right? So now you will be getting this kind of data. This is nothing but historical data. So you know, like, what happened in the past, like was the person eligible, or was the loan repaid or not. That's nothing but the supervised learning, as in, to teach by example. This is nothing but the supervised learning, and as in a teacher is saying that has happened in the past, now you need to take action on this. Okay, so what is the formal definition? It says that it's a type of machine learning algorithm that uses a known data set, training data set, to make the prediction, right? You'll be given the historical data, and on the basis of that, you'll be making the prediction, right? Now, unsupervised learning. Unsupervised learning as in, you'll not be given the historical data, right? And example for it is, now I am saying that, n number of users are accessing my website. So based on the, let's say on my website, there are 5 articles, article A, B, C, D, right? User 1 is reading article 1 and 2, user 2 is reading 3 and 4, so on. Now you are interested in creating groups based on user preferences. Do you think that, creating groups based on user preferences, historical data will help? No, right? Because the preference can change. So what is that? That's nothing but unsupervised learning, where you will not be given the historical data. Kids are taking decision out of their own understanding. This type of learning would be unsupervised learning. What do you have? You do have reinforcement learning. So yeah, let's move on. Now, reinforcement learning. It's like a new situation comes up, the kid will take action on his own, right? From past experiences. But as a parent, towards the end of an action, you can tell him whether he did good or not, right? So reinforcement learning as in autonomous cars. So now K means clustering. Okay, so here what you have is, you do have these data points. This is the X, Y, and you have plotted your data points. So we are interested in creating 2 groups. How do we start it, guys? This K means is nothing but is an example of unsupervised learning. So here you have plotted the data graphs. Now the point is, how do you start? Okay. So in that case, you need to understand this algorithm. So this algorithm says that, first of all, you can take 2 random centroids because you are interested in creating 2 clusters. So here what you will be doing, you are taking 2 random centroids, right? So you are saying that, okay, this is the centroid for this cluster, this is the centroid for this cluster. And after that, what you'll be doing, you will be calculating the distance of each point from the centroid. So now for each, like, you'll be calculating the distance for each point from the centroid. And how do you do that, guys? How do you calculate the distance between 2 points? This is the formula which we had studied in our mathematics, right? So you'll be applying this formula to calculate the distance. Now after that, the points will move, and then again a new centroid will calculate it, right? Again a new centroid will calculate it. Then again you will calculate the distance of each point, and you'll be saying that, okay, these points are the nearest to this centroid, and these points are the nearest to this centroid. This will keep on happening in the iterations. Okay, basically this will keep on happening in the iterations. And when will you stop it? So you will say that when the centroids are not moving, right? In that case, you can say that, yeah, we have created 2 clusters. Now you see, these things are part of cluster 1 and these things are part of cluster 2. So you see points are moving, right? So yeah, now your data is divided into 2 parts. First of all, what you did as a data scientist, like when you were given this requirement, right? You had applied this k-means clustering. Now for clustering, right, there are other algorithms as well. So you need to apply those as well, and you need to see which one is giving the best result. And now once you have got the result, right, you need to check like if you have got the correct output or not, right? Again, there are different ways. It will tell you if this is right or this is wrong, right? So again, you'll have to do the analysis. You'll have to work on the predictions. You'll have to work on the prediction. So guys, this is just to give you the idea. So other data scientists, you need to have the understanding of these formulas as well. And k-means clustering is the most simplest algorithm in linear regression. In machine learning. So we do have other algorithms, like we do have random forest decision tree, where we calculate the entropy or the randomness and n number of other things. This is just to give you the idea that yes, you need to have expertise on mathematical concepts as well. So now when it comes to the implementation, right? Now let's say that, I am interested in implementing linear regression. So basically here what you are doing, you are just reading the data wherever it is present. Okay. Then you are doing the data cleaning. Okay. And then you are just calling out this algorithm, let's say linear regression. Because we have discussed the concept of k-means, so here you will just say k-means. That's it. And then you will be getting the output. So now from implementation perspective, it's not a big deal. Anyone can write this code. The one who is not having the understanding on machine learning concepts, right, or the one who is not having the expertise on mathematics can also write this code. The only thing is what you are doing, you are just calling that API, right? But the point is, important thing is to know which algorithm should be called here. And now here, what you are doing, you are just calling this algorithm, right? And now let's say that it is giving this output, right? And it is saying that, this is the result. And accuracy comes out to be, here we are calculating the accuracy, right? Mean squared error is 98, right? And also you need to know what is this root mean squared error, what is this mean squared error. So now someone is saying that I'm interested in getting the accuracy more than 99. So you will say, how can I change that, because I've just called the API. In that case, you need to understand how this linear regression or how this k-means clustering algorithm works internally, so that you can optimize it. So yeah, guys, again, now I think it's clear that as a data scientist, what will be your role, and most importantly, mathematical expertise is needed. Thank you so much, guys.